Okay, good morning. Welcome to
FamilyMath number 854.
854. So today we're going to be talking about Newton's method, and you were just learning about algebra this year,
Yep.
right? And you were learning calculus.
Yep.
So this is technically a calculus topic, but I'm going to do it without a lot of calculating. Okay.
All right.
So one of the problems that comes up in math a lot is finding roots of equations. Do you know what that means?
It's like when the value of an equation touches the x-axis or the y-axis,
Yeah. What does that mean about the value?
where when x or y is 0.
Okay. Yeah, and usually when we're talking about roots of equations, it's where the y value is 0. So it's where, we're trying to find where f of x equals 0. Do you know any equations that you can find where they're equal to 0? Do you know how to do?
Maybe some linear equations.
Yeah, maybe some linear equations. Do you know any equations that you can find the values where they're 0?
Linear equations, all quadratics, and maybe a few cubics. I can see how to factor them.
Okay.
I know there's a formula for cubics like there is quadratics.
That's right. There's also one for fourth degree polynomials. Both of those, I think, were discovered by either an Italian named Cardano or Ferrari in the 1500s. I forget. One of them claimed to have discovered it, and the other one actually discovered it, but I forget which is which. Yeah, but a lot of times for a general equation, you just don't know. There's no way to do it. And so you have to do numerical approximations. So somebody named Newton, have you ever heard his name before?
Yep.
Where?
Isaac Newton.
Isaac Newton, yeah. Where have you heard his name?
Newton's laws.
Mm-hmm. Have you heard Newton's name
Yeah.
before?
Around gravity. Also, he was one of the. I think he was one of the founders of calculus.
Yeah, he sort of discovered calculus. So I'm going to focus on trying to find this root here.
All right.
Okay. And what Newton's method says is, hey, we don't necessarily know how to find that root. There's not necessarily a formula, but we're going to use some ideas from calculus, and those ideas involve something called a tangent line. And what you do is you have the function, you estimate, maybe, hey, here's the root here.
All right.
And then what I do is I say near that point, the tangent line and the function look very similar to each other. So the tangent line is just a line
That's kind of like touching the point.
that's kind of touching that point, and it stays very close to the function nearby, but it's a line. And what's the nice thing about lines and roots?
Nice. Well, you can kind of, if you know the equation of the line, you can figure out the root.
Yeah, so we say, well, that must mean the root. If we're near the root, if we somehow know, like, hey, there's a root somewhere nearby, if we're near the root, we get an approximation for the root. And then we use that as the value, the new value of the function where we're guessing. And we use the tangent line there. That gives us a new estimate for the root. Go up to the function, and then down. And we just sort of zoom in. Spiral into the root. So that's the idea. So why don't I have you do an example for me, just so you can tell me or show me. Let's just pick an easy one. Let's say we have a function. It looks like this. Maybe it's a quadratic, maybe it's not. Who knows? But it just sort of looks like this. Oh, actually, since you're sitting over on this side, we'll do it for this root. Why don't you take a guess at a value of the root?
All right.
Remember, you don't know where it is for sure, but you can take a guess.
Maybe around here.
All right, around there. Okay, so good. So now draw the tangent line.
Sort of like this.
Yeah. Now you hit the axis and you go up to the function. And then down. On the tangent line again. And up and down. And so what do you think about this method generally, now having seen a couple examples?
Well, I don't think you're ever going to actually get to the root, just going to get better approximations.
Okay. What do you think?
Well, I'm not sure if I'm not sure this method has error where you start too far away. Like maybe somehow if you started like up here, you went over here, and then you somehow got onto this side of the function.
Oh. Very interesting.
So maybe there's like a limit to how far you can start away from the actual location of the root.
Okay. Yeah, that's a good point. We're going to talk about that. But since you brought it up, can you show me a point where this method will definitely break?
It's right where it's flat right here.
Okay, you start there, and what's the problem?
You don't actually hit the axis ever.
The tangent line's horizontal. So you never hit the axis. So yeah, so even that simple example shows that Newton's method isn't going to always work.
Yep.
Okay. All right. So cool. Let's look at a broader example of this.